background noise. Okay, wait a minute. Okay, in the last class, we were studying about the unsymmetrical bending of symmetrical section. So just to give you or just to revise a few concepts. Okay, so as we discussed in the previous class, that in symmetrical section, unsymmetrical bending takes place when the loads are not acting on the principal axis. So for that case, if I want to find the stress, let's suppose at this particular point, if this is the beam, and if if this is the cross section of beam, and if I want to calculate the stress at this particular point, then in that particular case, I have to resolve this load or the moments that are acting onto the principal axis, and then from the principal movements I can calculate the stresses. Now usually in these cases the question or the type of question that you encounter are something like this one, for example, shown over here. Now in this question, if you see that there is a load E that is acting on the beam. Now this load I cannot show it in the inclined direction on the longitudinal section. So you have to look the diagram. Obviously this load is acting on the, see in the cross section, this load has some inclination with respect to the horizontal axis in the cross section. So you have to see in both direction to see where exactly this load is acting. So the questions are usually something like that, that there is a load which is acting on this particular beam and we need to report the stress at any point. For example, let's say at this point D or at this point A. Now previously and usually when you were applying the flexure formula, it was something like this one: sigma is equal to my over I. Now in that particular case, it was understood that the load was always acting directly on the principal axis. So symmetrical bending, you directly apply this particular formula to get the flexural stresses, but that is not the case over here when the load is applied. So to solve this question or to apply the formula, we have to make some small modification. And the procedure that we are going to follow is listed over here. That the first thing that we need to do is to the applied load or resultant moment. Now I will explain each point step by step, and if you have any question, you can stop me in between and ask me. Yes.
सर ये स्क्रीन आपने शेयर की है?
Yes.
आ रहे से नजर आ रहे हैं.
Okay. So coming on to this problem, let's suppose the load is being applied in this direction and this is the symmetrical cross section, and in this one obviously by default we know that this y and z axis are the principal axis, and we also know that when the load is acting on the principal axis, the bending is being produced on the axis or the axis which is perpendicular to this particular axis. Also I can call this axis as the moment axis, or in the case of symmetrical section, I can also as my neutral axis. By moment axis, this is not the term which we usually encounter. Yes.
सर आप कुछ लिख रहे हैं कि नहीं? ये कुछ नजर
यस सर स्टक हुई है.
स्टक हुई
है पूरे ख्याल से.
Right. Okay. Can you see now?
सर स्क्रीन नज़र तो आ रही है, लेकिन यहाँ पर जो अनसिमेट्रिकल बेंडिंग वाली वो स्लाइड है सर, वही नज़र आ रही है शुरू से.
मेरी
लिख रहे हैं वो
राइटिंग नजर आ रही है, मेरी राइटिंग
सर आपकी राइटिंग नज़र नहीं आ रही, आपने जो कुछ लिखा है अभी तक कुछ नज़र नहीं आया अभी तक।
redo. How about now?
नो सर, ब्लैक स्क्रीन नज़र आ रही है।
Black screen or
ब्लैंक
can you see the screen?
ब्लैक
ब्लैंक
स्क्रीन,
से
ब्लैक
ब्लैंक
ब्लैक सर, ब्लैक
सर ब्लैक विंडो नजर आ रही है सिर्फ।
से ब्लैंक स्क्रीन है सर।
ब्लैक है सर, ब्लैक।
Whiteboard नजर आ रहा है? Can you see the whiteboard now?
नो सर,
सर वही स्क्रीन
नो सर।
ब्लैंक स्क्रीन
ब्लैक, काला स्क्रीन सर, काला, ब्लैक।
This is strange. Okay, let me just disconnect this call and me join again. Can you see the whiteboard now?
Yes, sir.
अनसिमेट्रिकल बेंडिंग की।
Um, can you see my writing now? Oh, wait, no.
यस सर,
Yes, sir.
यस।
Okay. And wait, how about this PPT? Can you see it now? Now I'm writing over here. Anyone, quickly. Can you see it?
No, sir.
So I think
Writing
this.
up. No, sir. There is no writing, sir.
Okay, so I believe there is some issue with PPT, so let's stick to the whiteboard. So anyway, coming on to this unsymmetrical bending, I was telling you that the questions that you may encounter are something like you will be given a beam, and on that particular beam, this kind of a beam, and on that beam, you will have some inclined load in the cross section, and you have to transform that load. Now we know that we can only apply the flexural formula when the load is acting directly parallel to the principal axis, so that bending takes place around the neutral axis, or what I can call as movement axis. So this term movement axis, you won't find this term much in the literature, but I am using it just for the sake of convenience, that the axis around which the movement is taking place, we can call that as movement axis. And in the case of symmetrical section, when the loads are on principal axis, we can also call this axis as the neutral axis. So to solve these kind of questions, the first step that I have shown you in this particular slide was we need to find the inclination of the applied loading or the resultant movement. Now, how can we do that? We can simply, for example, let's suppose if this is, let's suppose if this is my beam, or this is the cross section, and the load is acting in this direction. So can I say that there will be an axis which is 90 degree? I can just transform this load over here, and I can say that there is an axis which is 90 degree to this applied load on which the bending moment is taking place, right? Is there any, it is just a similar concept. Straight axis होता था या directly इधर load लग रहा होता था straight, तो क्या होता था, एक 90 डिग्री पे axis होता था जिसके अराउंड bending moment प्रोड्यूस हो रही होती थी. In similar way, I can also say that when the load is being applied inclined to the cross section, there will be an axis which I can call as moment axis, around which the bending is taking place, right? So over here, I have shown bending something like this one. And in the next step, what we can do, we can transform this, before moving on to transformation, I just want to add another concept over here. We have to do the transformation on of this moment onto two principal axes. Now, in the case of this rectangular cross section, I know that my principal axes are this y axis and z axis. Okay, so I have to transform this moment onto this z axis and y axis. Now, how can I transform? Obviously, it is difficult and it will make things confusing if I keep on representing this movement in this clockwise or counterclockwise term. So to ease out this confusion, there is another concept of representing the movement. This circular movement or this circular representation of movement can be represented in the form of double-headed arrow. So the load, we keep on representing the load with a single-headed arrow, and the movement you can represent it with a double-headed arrow. And how to, and what is the sign convention, or how whether we have to show it outwards or towards the axis, that we will discuss in the next slide. Okay, so for now, you can say that when the load is acting, there will be some kind of bending moment or bending that will be produced in an axis which is exactly 90 degree with respect to the applied load. And that bending moment, now this is the bending moment, now this bending moment can be transformed into two components along the principal axis. One is this mz, the other component will be my. So I will have two components of this applied load, or the moment due to applied load. Okay, so these two components are shown over here. This one as mz, which is m cos theta. Now m is the moment which is acting on the axis. If the load is this one, then m is the moment which is acting on this axis, which let's call this as m axis or moment axis. Okay, so now this moment has been transformed onto two axes. There is a plus sign over here, or you can write it equals to. This is simply the principle of superposition. Anyway, and the second component is this my component, which is my is equal to m sine theta. So this is how you transform the moment. जब आपके पास ये movement transform हो गया है, so now you can separately apply the flexural formula on each case. For example, for this mz, my flexural formula is mz y over iz. Simple, like you were used to doing this one. My over I. Moment is the simply the moment which is acting on the cross section. Y is the distance perpendicular to that moment axis, and I is the moment of inertia. Okay, now this I will also be either Iz or Iy. For mz case, it will be Iz. And similarly, if I want to represent the flexure formula for this one, can anyone tell me what will be the flexure formula for this case, for this my moment? Anyone? इसके लिए क्या होगा flexure formula?
my into y over iy.
So that will be my into z over iy. Because z is the distance perpendicular. अब इस केस में आप क्या करते थे, इस perpendicular distance को लेते थे. सिमिलर केस यहाँ पे है, इधर अब मूवमेंट आपके पास प्रोड्यूस y एक्सिस पे हो रहा है, और इस y एक्सिस के परपेंडिकुलर जो भी डिस्टेंसेस हैं वो z से रिप्रेजेंट होते हैं. सो दैट्स व्हाई वी हैव टू रिप्रेजेंट द डिस्टेंस विद दिस z एक्सिस, राइट? सो
सर इसको सिग्मा y कहेंगे.
अभी इसको आप सिग्मा y कह लो और इसको सिग्मा z कह लो, ठीक है. अब लेट सपोज इफ आई आस्क यू कि इस पॉइंट पे, लेट सपोज देयर इज अ पॉइंट समवेयर ओवर हियर. If I ask you that give me the stresses at this particular point due to this load P or inclined load P which is acting on this beam, now how can you do that? First, you will calculate the stresses due to this Z component or this Z stresses which I have represented with sigma Z. You can simply use this formula and apply this one and get the stresses. Then in the next step, you will calculate the sigma y stresses at this particular point by using all these, by substituting all the values. And once you have these two values, then you have to either add them or subtract them to get the value of stresses, or to get the resultant stress at this particular point which I have shown, or I can call as point A. Now let's say the stress is mzy over I, and the second one is myz over iy. Now, can anyone tell me how can I figure out whether I have to add them or subtract them? Anyone? How will we find out कि हमने इनको ऐड करना है या माइनस करना है?
सर हम लोग ये परपेंडिकुलर डिस्टेंसेस को देखेंगे. अगर ये
ये देखेंगे कि टेंशन में है या कंप्रेशन में है मतलब फोर्स.
Yes, the basic concept is about tension and compression. You don't have to worry about perpendicular distances if you are following this concept. कि आप tension, अब यहाँ पे देखो, इधर आपके पास you know that this particular movement is acting in this direction. Obviously ये तो just as an example show किया हुआ, you will do by yourself जब आप examples कर रहे हो. तो यहाँ पे क्या हो रहा है आपके पास कि टॉप वाला जो सेक्शन है that is in compression, right? अब मेरा पॉइंट कहाँ पे लाई कर रहा है? अगर मैं इसको भी 4 क्वाड्रेंट्स में डिवाइड कर दूं तो मेरा पॉइंट इस फर्स्ट क्वाड्रेंट में लाई कर रहा है, ठीक है. अब इधर भी मैंने अगर इसको 4 में डिवाइड कर दिया तो यहाँ पे लाई कर रहा है. अब ये जो लेफ्ट फिगर है यहाँ पे आप देखो तो टॉप पोर्शन आपका कंप्रेशन में है और बॉटम पोर्शन टेंशन में है. तो मतलब ये जो mz की वजह से स्ट्रेसेस हैं, दीज आर कंप्रेसिव स्ट्रेसेस, राइट? तो अगर हम कंप्रेशन को कह लें कि जी ये नेगेटिव है, ठीक है, तो वी विल हैव अ नेगेटिव साइन विद दिस वन. एंड नाउ लुक इनटू दिस फिगर. अब इस फिगर में जो डायरेक्शन शो की हुई है दैट इज दिस वन, ठीक है. ये आप बाद में डिसाइड करोगे अपने अकॉर्डिंगली, लेकिन फॉर नाउ द डायरेक्शन इज समथिंग लाइक कि जो लेफ्ट पोर्शन है वो बाहर को निकल रही है, ठीक है, उसकी स्ट्रेसेस बाहर को निकलने का मतलब क्या है कि टेंशन में आ रही हैं, और जो राइट पोर्शन है उसके इनवर्ट्स जा रही हैं। और इनवर्ट्स का क्या मतलब है कि राइट पोर्शन इज इन कंप्रेशन एज वेल। अब मेरा पॉइंट जो इस फिगर में मैं देखूं तो दैट इज इन फर्स्ट क्वाड्रेंट एंड दैट इज आल्सो इन कंप्रेशन फेज। ठीक है, तो इस क्वाड्रेंट में अगर मुझे स्ट्रेसेस फाइंड करनी है तो आई विल सिंपली पुट एन अ नेगेटिव साइन विद दिस वन। ठीक है, तो दिस विल बी माय resultant stress which is acting at point A. Now this is one way to figure out the resultant stress. अब actually ये concept बना इस तरह से है कि you have to look के tension में है या compression में है. What? I can't hear you. So yes.
सर ये हम एरो की डायरेक्शन से देखेंगे भाई, ये टेंशन में है कंप्रेशन में, क्योंकि वो एक ही वक्त में टेंशन भी हो रही है कंप्रेशन भी हो रही है।
आप बेसिकली आप ये एरोस की डायरेक्शन किससे लगा रहे हो, ये इस मूवमेंट से लगा रहे हो, ये जो मूवमेंट की डायरेक्शन लगी हुई है। ठीक है, अब ये मूवमेंट इस डायरेक्शन में लग रहा है। फॉर एग्जांपल यहाँ पे देखो तो ये इस तरह है, अब ऊपर वाला एरो इनवर्ट जा रहा है तो ये इधर देखो ये सारे एरो इनवर्ट शो किए हुए हैं। इनवर्ट का मतलब कि आप अंदर को फोर्स लगा रहे हो, यू आर ट्राइंग टू कंप्रेस द सेक्शन। ठीक है, तो ऊपर वाली साइड पे कंप्रेशन हो रही है, और जब एक साइड कंप्रेशन में तो ऑब्वियसली द अदर वन विल बी ऑपोजिट टू दैट वन एंड दैट इज इन टेंशन, राइट?
ओके सर, ओके सर।
सो अब नाउ लुक इनटू दिस फिगर। अब इस फिगर में भी सेम चीज शो की हुई है। यहाँ पे दोनों स्ट्रेसेस ऐड हो रही हैं, बाय ऐड और सब्ट्रैक्ट सेम थिंग। अब या माइनस कर लो या ऐड कर लो, क्योंकि अब मैंने इधर नेगेटिव शो किए क्योंकि दोनों कंप्रेशन में है, और एब्सोल्यूट आंसर दैट विल बी सेम थिंग। नाउ इन दिस क्वाड्रेंट यहाँ पे एक स्ट्रेस ऐड हो रही है। अब नाउ लुक इनटू दिस वन इज इन टेंशन एंड ऑन द राइट साइड that is in compression, so you have to take the difference of these two stresses. Now if you are in third quadrant both of these stresses are in tension, so you have to take the sum. Over here if you see, we are taking the sum of the stresses. Now if you are in second quadrant, both of them are in compression. No, one will be in tension, this one, the third figure, if you see the third figure, one is in tension, the other one is in compression. So we have to take the difference of the two stresses to find out the direction. Now one way is this one, that you put in the arrows and based on those arrows you specify that based on the z-axis either the top section is in tension or the bottom one, and in the same way based on the y-axis movement you will specify either the right side is in tension or the left side is in compression. Now the concept was built based on that particular assumption. अब एक तरीका तो ये है. Now there is another method to figure out the direction or how to specify whether we have to add them or subtract them. We will fix the direction. For example, I will say in all questions that my y-axis is acting is in the upward direction, positive y-axis, and my positive z-axis is towards the left side. Now I will fix the axis, and what I will do, I will change the signs or signs of movement. For example, let's suppose I will fix that my y-axis is upward and z-axis is towards the left side. Now if I look into this figure, if I want to, let's suppose, calculate the stress at point A, which is located in the second quadrant, okay, because second quadrant is positive for both cases. Now if I want to find out the stresses in the second quadrant, what will be my equation? Can anyone tell me the equation? क्या करना होगा मुझे? कौन सी स्ट्रेस पॉजिटिव होगी and which one will be negative? If I write the equation of stress at A, I will have two components, that is for sure, mzy over iz. Then the second one, I'm not showing the sign for now. The second one will be MYZ over IY. So for if I take tension as positive and compression as negative, so over here, which sign I should put with MZ or with this component? Anyone? Will it be positive or negative? 193.
यस सर
इसके साथ पॉजिटिव साइन आएगा या नेगेटिव?
सर पॉजिटिव है.
Over here, if you look into this figure, A point is in the second quadrant. So second quadrant में क्या प्रोड्यूस हो रहा है? टेंशन है या कंप्रेशन है? Due to MZ.
Compression है sir.
The arrows are going inside. That means that it is trying to compress the cross section. So I have to substitute the negative sign with this one. And if you look into this second figure, due to this MY, I have in the second quadrant tension forces because the arrows are coming outwards. So I will say that there is a positive sign with this one. Now what I have done over here, that I have made one generalized equation for all positive senses, right? My movement was acting in the quadrant where everything was positive. This y and this z axis, y was positive in the upward direction, this z. Now what I can do, I can fix my axis and I have one generalized equation. Now if I want to find out the stresses at any point, I will simply look into this direction of movement. Now let's suppose I have a question in which my movement is acting over here or the resultant movement is somewhere here. Now I have to transform the movement. What will happen? My movement will be acting towards the right side, or MZ is towards the right side and My is towards the upside or in the upward direction. Now what will I do? I will use the same equation with the same arithmetic signs, and what I will do, I will substitute with mz. Let's suppose if mz comes out to be minus 10, I will simply put in minus 10 over here. And similarly with my, now this my is acting in the positive y direction. So I will keep this my as positive 10 if its answer is positive 10. Since mz is in the negative z direction, so that will give me directly so I have to put in the negative sign with this one. Now in the same way with this y or z distances, if my point is located somewhere on the right side, then what I have to do, I again have to see if it is in the positive y direction or positive z direction. Now if I see the z axis, this point A is in the negative z direction. So I have to put in negative 5 if the distance is 5 millimeter or something like this. And if I look into y-axis system or with respect to y-axis, my point is in the positive y direction. So when I will be substituting, then I will put in plus 5 or whatever the distance is given in the y direction. So either you can use the first method in which you have to look into this arrow direction, and then you have to either plot this stress diagram, and based on this stress diagram you will say, okay, my left side is positive and right side is negative, and then you will solve and so on. Or you can use this generalized equation and play with the signs of mz, y and z. Over here I have mentioned, yeah, in this diagram I have mentioned in the problem that we are going to solve, I will be using this resultant stress equation, and I will change the signs of this mz, my, z and y. If they are in the positive direction, then I will keep them as positive, and if any of them is in the negative z or y direction, I will change the sign convention accordingly. But both methods are fine, and you will get uh, same answer with either of them. So for the to begin with, I suggest you to use this equation and play with the sign. And once you are perfect in solving these sort of question, then you can switch on to the method one, in which you will see the orientation of movement or rotation to find out the signs. But both of these, and in the literature also, you will find both methods. So it's up to you that which one you will use. So this is about the sign convention of the movement. and and there is another thing, that how we can figure out, because the question will be giving us the direction of loading. It won't be providing that in which direction the movement are acting, or where should we put in the double-headed arrows. For example, yes,
जी एम जेड एम एम वाई जो है सर, ये दोनों एक डायरेक्शन में हो सकते हैं सर, या दोनों अपोजिट होंगे सर?
they can be in the same direction. Actually इनकी डायरेक्शन सेम कैसे हो सकती है वैसे? एम जेड जो है वो तो जेड एक्सिस पे लग रहा है, और एम वाई जो है वो वाई एक्सिस पे लग रहा है, तो सेम का क्या मतलब है?
मतलब
ये हो सकता है कि दोनों पॉजिटिव हो,
दोनों कंप्रेशन में हो या दोनों
हाउ मूवमेंट कैन बी, मूवमेंट के केस में आप ये नहीं कह सकते कि वो दोनों कंप्रेशन में है. यू कैन ओनली से कि वो एक साइड को कंप्रेस कर रहे हैं. अब जब एक साइड को कंप्रेस कर रहे होंगे तो दूसरी को ऑब्वियसली वो, देखो जब आपके पास ये बीम होती थी, ठीक है, तो ये मूवमेंट लग रहे होते थे. अब ये मूवमेंट क्या कर रहे हैं? टॉप साइड को कंप्रेस कर रहे हैं, बॉटम साइड को टेंशन प्रोड्यूस कर रहे हैं.
यस सर.
आपका क्वेश्चन क्या है इसमें?
तो बस समझ गया सर, समझ आ गया.
So let's suppose now the question is, how can we figure out, or how should we determine कि हमारा जो resultant movement है उसकी double headed arrow की direction क्या होगी, which I was discussing just in the previous slide. Now in most of the cases, let's suppose this is 20 and the total distance is 10, and if the question asks you that this 20 is acting somewhere over here, and this is 10 meter, and it will ask you that give me the maximum stresses at point A. Now let's suppose this point A is located over here. So the first step is that we need to find out the movement. Now since I have to find the maximum stress, so stress, the formula for stress is this one. So for maximum stress, obviously I need the maximum movement, right? So what will be the maximum movement of this beam? What will be the maximum movement?
सर मिडिल में होगी.
So what will be the value of that maximum movement?
20, sir.
I have to solve this one. That will be 10 if this is acting in the center, obviously.
50.
Okay, so in that particular case, the maximum movement is 50, right? So I will say that the movement is 50. Now what we are doing when we are plotting the shear bending moment diagrams, our convention is that we start from the left side and then move on towards the right side. Okay, so keeping in mind the same convention, can you tell me that which force is producing this 50 kilonewton movement, or which reaction is producing, or which load is producing this 50 kilonewton? After I resolve this one, can I say that this 10 kilonewton meters is causing this 50 kilonewton when we are plotting? Don't worry, because obviously we know that this 50 kilonewton is due to this applied load. But while plotting the bending moment diagram, this 10 kilonewton reaction is producing this 50, because we are multiplying this 10 with 5 and we are getting 50, right? Is there any confusion about this one? So if there is no confusion, then I can just move on from this one. Now the first thing is that 50 is produced by 10 kilonewton reaction force, or 10 kilonewton force on the left side of this beam. Okay. The second thing is that the direction of this 50 kilonewton is clockwise. Okay, because we know that at this point, if I take the moment, it is acting in the clockwise direction. So what you have to do, you have to figure out what is the resistive force to this 50 kilonewton. Now this 50 kilonewton meter is being produced in the clockwise direction, and the resistive bending moment is counterclockwise. There will be another moment of 50 kilonewton meter, or the beam has to produce the moment of 50 kilonewton meter to resist this one. Now, if this resistive bending moment is counterclockwise, what you can do is, now you have to show the double-headed arrow pointing towards the centroid of this beam. Oh, sorry, away from the centroid. Now, what is the concept? That you have to find that which load is producing this 50 kilonewton meter, and then based on that particular load, for example, in this one, this 10 kilonewton force is producing the 50 kilonewton, and based on this particular force, you are going to find the moment. We figured out that the movement is clockwise, and then in the third step you have to find that what is the resistive movement. Obviously, if this is clockwise, then resistive is counterclockwise, and based on this resistive bending moment, you have to specify these double-headed arrows. And I figured out that these double-headed arrows are counterclockwise, and if these are counterclockwise, then I will just show it over here, moving or towards outside or from this centroidal axis. Again, if this resistive is clockwise, then you have to show them acting inwards in this beam. And there is another way. For example, can I say that the moment axis is this one, or the axis on which moment are acting? So this moment axis is what? This is basically the axis of this beam, right? This is this beam, or uh, since the load is acting inclined to this particular beam, I can say that this beam is something like this one, and you have to show this movement arrow on the same side at which the load is acting. For example, over here, the load is acting towards the left side, so you have to show these double-headed arrows towards the left side. This is the left side of the beam, and this is the right side, right? I know that this load of 20 kilonewton is acting perpendicular to this beam. This is the left side, this is the right side. Now, if let's suppose the load was acting, or let me use another pointer. Let's suppose if the load was acting something like this one, this longitudinal section would remain same. And I would say that in the cross section, the load is acting with this, which I have shown with this blue arrow. Now, in this case, what would be my moment axis? Can I say that my moment axis is perpendicular to this one, right? Now, what is my left side? This is left side, and on this left side, if I look into the longitudinal section, there is a hinge support, and on the right side there is a roller support. And now in this case, if I want to represent the counterclockwise movement or the direction of the resultant movement, that will be shown over here, and it will be same movement of 50 kilonewton meter. So you have to be very careful about plotting the direction of resultant movement. First thing, I have just summarized the few conventions that you have to follow. First, you have to find, if it has been asked that give me the maximum stresses, then you have to find the maximum bending moment, or you can just plot the bending moment diagram quickly, and from that bending moment diagram you will get the idea that this 10 kilonewton or this reaction is producing the bending moment. Then based on that reaction, you will find out that the direction is clockwise, and then you have to figure out that what is the resistive moment. Obviously that will be opposite to that one, and based on that resistive bending moment, you will specify the double-headed arrow in your cross section. And once you have this double-headed arrow, then you can simply transform this double-headed arrow onto your principal axis. Now in this case, obviously we know that this is the rectangular cross section, so our principal axis with the will be this y and z axis, and I can, if I know this angle in between this one, I can simply transform these two movements onto my principal axis, and once I have transformed, I can simply use my formulas to calculate the stresses or the resultant stress at any particular point. Now, you may ask the question that why we are taking the resistive bending moment, not the original clockwise moment. Obviously, we can take that as well. But in that case, since again, I would use the same terminology that we have to be consistent with the literature or what everyone is following. For example, over here, we are taking the clockwise movement or showing clockwise movement as positive or towards the upward side. Obviously, someone can ask the question that why you are not showing it towards the downward direction. We can do that, but again, to be consistent with everyone or to be consistent with the literature, we have to follow some set of convention. And for this particular scenario, the convention is this one. So now, any
Excuse me,
question
sir.
about how to repeat? Yes.
सर ये जो आपने स्पोर्ट पे लिया हुआ है 10 वाली फोर्स, अगर सपोज मतलब दरमियान में कोई और फोर्स भी होती तो फिर हम मैक्सिमम किसके लिए कंसीडर करते हैं? मतलब अभी तो आपने सपोर्ट लिया है ना, सपोर्ट से मतलब
यस,
आप कह रहे हैं
अब लेट सपोज दरमियान में कोई और फोर्स होती, ठीक है, तो हमें ये तो पता लग जाता ना कि क्लॉकवाइज मूवमेंट है या काउंटर क्लॉकवाइज मूवमेंट है इस सेंटर 50, और जो काउंटर क्लॉकवाइज ये फोर्स होती है अगर 5, तो काउंटर क्लॉकवाइज कितना आ रहा होता है 5 इंटू 2.5, ठीक है, तो फाइनल रिजल्टेंट क्या होता है, वो तो क्लॉकवाइज डायरेक्शन में ही आता ना, क्योंकि क्लॉकवाइज ज्यादा वैल्यू है, उसमें से थोड़ा सा माइनस किया हमने 5 इंटू 15 और समथिंग हमने इसमें से माइनस किया है, तो हमारे पास फाइनल आंसर तो फिर भी क्लॉकवाइज मूवमेंट प्रोड्यूस होता है, राइट। तो इस तरह से आप स्पेसिफाई कर लोगे कि जी फाइनल मूवमेंट क्लॉकवाइज प्रोड्यूस हो रहा है और रिजल्टेंट और रेजिस्टिव उसका काउंटर क्लॉकवाइज है, एंड बेस्ड ऑन दैट यू विल स्पेसिफाई द डायरेक्शन। इज इट क्लियर?
ओके सर।
एक्सक्यूज मी सर।
यस
सर ये जो क्लॉकवाइज रेजिस्ट और बेंडिंग मूवमेंट आपने लिया है सर, ये आपने क्रॉस सेक्शन पे किस तरह ड्रा किया सर, ये समझ नहीं आया।
दिस वन,
यस सर, यस सर।
देखो ये मैंने फर्स्ट केस के लिए ड्रॉ किया, ये जो ब्लू वाला है इसको भूल जाओ फिलहाल। अब क्रॉस सेक्शन में ऐसे प्लॉट किया है कि बेंडिंग किस एक्सिस पे प्रोड्यूस हो रही होगी। लोड मेरा यहाँ पे लग रहा था 20 इनिशियली, लेट मी जस्ट शो, इनिशियली लोड ये था 20, राइट, दिस वाज 20। अब बेंडिंग किस एक्सिस पे प्रोड्यूस हो रही होगी, इसके परपेंडिकुलर एक एक्सिस होगा व्हिच आई हैव शोन विद द ग्रीन लाइंस, ओके। अब ये मैंने शो कर दिए ग्रीन लाइन के साथ परपेंडिकुलर। अब मुझे इतना पता है कि इस पे बेंडिंग प्रोड्यूस हो रही है। अब मैंने ये स्पेसिफाई करना है कि जी इसको मैंने इस एक्सिस पे मैंने मूवमेंट बनाना है या मूवमेंट का डबल एरो बनाना है, तो वो मैं किस साइड पे बनाऊं और उसकी डायरेक्शन क्या होगी। तो फिर मैं क्या करूंगा, मैं दोबारा से अपने लॉन्गिट्यूडनल सेक्शन पे आऊंगा और उस पे देखूंगा कि लेफ्ट साइड पे जो फोर्स थी ना उसने प्रोड्यूस किया, तो आई विल सिंपली से कि मैं लेफ्ट साइड पे प्लॉट करूंगा अपना मूवमेंट। अब मैं इधर एक सपोज कर लूंगा कि ये जी मेरा एक्सिस है, लेफ्ट साइड पे हिंज है, ये आप ना भी करो तो इट्स जस्ट एन इमेजिनरी थिंग। तो मैं क्या कहूंगा, ये मेरी लेफ्ट साइड है जो कि ये ऊपर को जा रही है, दिस इज लेफ्ट साइड, दिस इज राइट साइड। अब पहली चीज ये क्लियर होगी कि लेफ्ट साइड पे शो करना है। अब लेफ्ट साइड पे एरोस बाहर को लगाने हैं या अंदर को लगाने हैं, वो आपकी ये चीज शो करेगी। अगर रेजिस्टिव बेंडिंग मूवमेंट काउंटर क्लॉकवाइज है तो एरो अवे फ्रॉम द सेंट्रल एक्सिस या सेंट्रॉइड, ठीक है, सेंटर पॉइंट। अगर रेजिस्टिव क्लॉकवाइज आ जाता तो आप इसके एरोस इस तरह से लगाते, और वंस यू हैव दीज एरोस उसके बाद तो थिंग्स विल बी क्वाइट सिंपल, you simply have to resolve or transform and you will get the stresses. Is it clear?
ठीक है सर। ये जो बेंडिंग प्रोड्यूस हो रही है तो आपने सर किस तरह कहा कि इससे सपोर्ट से प्रोड्यूस हो रही है सर, दूसरे से भी हो सकती है सर?
दूसरे से भी हो सकती है, दोबारा बताओ दूसरा क्या?
सर दो सपोर्ट्स है ना सर,
ऑब्वियसली दूसरे से भी हो सकती है, उस केस में फिर आपकी सारी कन्वेंशन ऑपोजिट हो जाएगी। ठीक है, दूसरा भी 50 ही प्रोड्यूस कर रहा है, उस मैं ये नहीं कह रहा वो नहीं प्रोड्यूस कर रहा, लेकिन मैं वही बात कर रहा हूँ कि हमने तो ये शो करना है ना, किसी तरह इस 50 को रिप्रेजेंट करना है इसके अंदर। ठीक है, तो हम एक साइड को यूज करते हुए उसकी कन्वेंशन, अब जिस तरह बेंडिंग मोमेंट डायग्राम है, आप राइट साइड से भी बना सकते हो, लेफ्ट साइड से भी बना सकते हो, बनेगी तो सेम। ठीक है, लेकिन जब आप लेफ्ट राइट साइड से बनाते हो तो कन्वेंशन ऑपोजिट हो जाती हैं, लेफ्ट से चल रहे होते तो एक होती है, राइट से तो दूसरी हो जाती है। ठीक है, तो it both loads will be producing that one. So we usually stick to the left side क्योंकि हम सारा काम उससे करते आ रहे हैं. So let's solve one question quickly to get an idea how to apply this resultant stress equation. Can you see this question?
Yes, sir.
Yes, sir.
So in this question, there is a rectangular cross section on which there is a moment of 12 kilonewton meter that is acting, and we have to figure out the normal stresses at points B and D. B is this top left and D is this bottom left. So let me just plot it quickly on this whiteboard. And you don't have to worry about the orientation. No matter in which shape it is given, just plot it in 2D as per your own convention. For example, in the book, you may find it something like this one. And if you want to solve it, you will simply plot in 2D plane as per on your convenience. Okay, so again, as I told you previously, that we will fix our Y and Z axis something like this one. Y-axis towards top and Z-axis towards left side. Okay, and based on this figure, if I see that this load is acting in this quadrant, can I show it something like this one? And this is, by the way, movement, so we have to show it with double arrow, right? This is my movement. And what else? I have been given the length. This is 0.1 meter. This one is also 0.1 meter. And then from this cross section, I have the length as 0.2 meters, each 0.2 meter ZY, and this is point C, this is point B, and this is point D and E. And I need to find out the stresses at point B and point D. Yes. So these are the 2 points on which I need to find out the stresses. So the first, or now in this question, you are not provided with any loads or anything else. So for now, our things are simple, that we don't have to worry about how to represent the moment or how to calculate the maximum bending moment. So that we will keep it for the next few questions. Now in this one, directly you have been provided with the moment and you need to give me the stress at point B and D. So the first step, it will remain same, that I need to calculate the bending moment on this, or I need to transform this bending moment which is acting at any random axis onto my principal axis, which are Z and Y axis. So for that, I need to know this angle. So can anyone tell me what will be this angle? We have been provided with this triangular shape or to this specification. If I represent it over here, it is something like horizontal is 3 and vertical is 4. So what will be this angle?
Sir, 53.13. 53
So
degrees.
that will be obviously tan theta equals to 4 by 3 and theta will be 53.13 degree. So I know that angle is 53. And now what will be mz, or the horizontal component of this movement? It will be in this direction, and I can call this as mz, and my will be in downward direction, and I can show it over here. So what will be mz?
Sir, 7.2.
So mz, if I calculate, that will be 12 cos of 53.13, and yes, the answer will be 7.20 kilonewton meter. And what about my? Anyone? Quickly.
9.6, sir.
So same
9.5.
way, that will be 12 sine of 53.13, and it will give me my as minus 9 point, or I can just keep it positive for now. Okay, so this will be my my. So now I have both the moments my and mz. And the next thing is simply I have to apply my stress equation. Let's suppose I write it for sigma b, that will be minus mz y over iz plus my z over iy. So what is iz by the way in this one? That will be bh cube over 12, and width is 0.2, height is 0.2, 0.4 cube divided by 12. So what is iz? What will be the value of iz?
Sir, 1.06 into 10 to the power minus 3.
So that will be 1.06 into 10 minus 3 meter 4. What about iy? In iy, obviously these two will be opposite. So that will be 0.4 into 0.2 cube divided by 12. So what will be iy?
2.67 into 10 raised to power minus 4.
So let me give, that is 0.266 into, you can cross check this one. I have this answer with me, minus 10 minus 3 meters 4. Okay, so now I have iz and iy, and first I need to find out the stresses at point B. Now by method one, the second method that we learned, we will substitute the values of mz. So what will be the sign with mz? Should it be positive or negative?
Positive, sir.
Since it is in positive z direction, so we will take it as 7.20. What about this y? Will y be positive?
Positive, sir. 0.2.
Since this b is in positive y-axis or positive y direction, so that will be 0.2. Okay, so this is about y. Then what about my? Will it be positive or negative?
Negative, sir.
Negative. So my is negative, and I will put in negative 9.60. What about again this z? Will
That's
z be
negative, sir.
positive or
Negative
negative?
0. Point minus 0.1.
So
Negative,
that
sir.
will be negative 0.1. And what about, and that will remain same, the last thing, 0.266 into 10 minus 3. And by the way, if we want to get the answer in megapascal, then we have to convert these moments into Newton. So multiply this one with 10 raised to power 3 and this one also with 10 raised to power 3. So what is stress at point B?
एक्सक्यूज मी सर
Yes.
सर ये साइन बता दे ये mz my का साइन किस तरह नेगेटिव पॉजिटिव है ये समझ नहीं आया सर
देखो इधर mz आपके किस डायरेक्शन में आ रहा है, ये पॉजिटिव z डायरेक्शन में,
सर
तो पॉजिटिव z डायरेक्शन में होगा तो पॉजिटिव या उसका साइन पॉजिटिव है। इसी तरह my देखो ये नेगेटिव y डायरेक्शन में, y पॉजिटिव अपवर्ड साइड पे है ये एक्सिस सिस्टम में, तो my डाउनवर्ड लग रहा है, यानी नेगेटिव साइन आ गया उसके साथ, ठीक है।
तो z एक्सिस लेफ्ट तरफ, लेफ्ट की साइड की तो पॉजिटिव है सर।
हाँ जी, हमने जब ये इक्वेशन बनाई थी, ये वाली इक्वेशन, तो हमने कन्वेंशन क्या ली थी कि z जो है वो लेफ्ट साइड पे पॉजिटिव है और y जो है वो राइट साइड अपवर्ड पॉजिटिव है। और एक चीज का ख्याल रखना, ये जो नेगेटिव साइन है ये इक्वेशन में रहेगा। ऐसे हो सकता है कि यहाँ पे भी नेगेटिव आ जाए और फिर नेगेटिव नेगेटिव प्लस हो जाए, तो आपने इससे कंफ्यूज नहीं होना कि आप इस साइन को खत्म कर दो जब mz पॉजिटिव हो, ठीक है। तो ये नेगेटिव साइन एज इट इज बाय डिफॉल्ट इक्वेशन में, ठीक है।
ठीक है सर।
तो what is sigma b?
Sir, 2.25.
So that is 2.25 megapascal. Now in the same way, the second thing is that I need to, okay, before calculating the stresses for point D, हम एक काम करते हैं, हमने जो पहला मेथड पढ़ा था कि बेस्ड ऑन हम उसकी बेस पे जो हमारे पास जो stress based on the direction of tensile and compressive forces, can we find out the stresses based on that? So let's just try this, give me a moment. Okay, now coming on to that one. Now for that you have to use your right hand rule. Now what was the right hand rule? You will simply point the thumb of your right hand in the direction of movement, क्योंकि आपको मेन पता करना है कि इधर इस मूवमेंट विच इज दिस mz मूवमेंट, इस mz मूवमेंट की वजह से टॉप साइड पे कंप्रेशन हो रही है या टेंशन हो रही है। सो फॉर दैट यू नीड टू सिंपली यूज राइट हैंड रूल फर्स्ट टू फिगर आउट के टॉप साइड पे हो क्या रहा है। सो फॉर mz, point your thumb in the direction of this mz and roll your fingers. तो I am going to get something like this direction, मतलब कि टॉप साइड जो है वो कंप्रेशन में जा रही है और बॉटम साइड जो है वो टेंशन में जा रही है। सो आई विल जस्ट राइट इट डाउन दैट ड्यू टू mz, top is in compression, okay, and bottom side is in tension, okay. So one thing is this one. Now can you tell me that due to my, what will be the forces on the right side and what will be the forces on the left side using the same rule?
Lift is in compression
राइट
or
साइड पे सर टेंशन क्या होगा और लेफ्ट साइड पे
So the
लेफ्ट साइड पे
arrows,
टेंशन क्या
if
होगा?
I want to represent, it will be something like this one. The left side will be in tension, compression, and the right side will be in tension. Okay, so I will just write it over here that due to my, left side is in compression and right side will be in tension. Okay, so now my point B is located over here in this block. Now in this block, if I, okay, I will write it over here. In this quadrant, will sigma z be positive or negative? Since it is in compression, so I will take it as negative, right? Any confusion about this one? Negative sigma z, because I know that due to mz, my top section is in compression, so I'm taking negative sign with sigma z. And what about sigma y? Will it be positive or negative? Quickly.
positive, sir.
Positive. So I will have positive sigma y. So if I calculate again, now in this one, I don't have to worry about the signs of my and z. I can directly get the answer. So if I again I know my equation will be something like, sorry, over here it will be sigma z and over here it will be sigma y. I will simply substitute mz y over I plus my z over iy. Over here it will be iz. So if I calculate this one, mz I calculated as 7.20 into 10 raised to power 3. Iz we calculated as 1.067 into 10 minus 3 plus again my was 9.60 into 10 raised to power 3 divided by this was 0.266 into 10 raised to power minus 3. Now again if I look into this figure, I know that y distance is for this point B, the y distance is 0.1 and z distance is 0. Y distance is 0.2 and z distance is 0.1. So I will substitute these distances y as 0.2 and z as 0.1. Now, can you give me the answer for this one? Quickly, can you give me the answer for this stress?
Sir, 2.03.
Uh, it is again 2.25. So maybe if you made some error or something, because when I solved it, I got the answer as 2.25. Anyway, you are also close, so maybe it is due to this number of significant figure. So the idea is that whether you take the sign convention based on first method in which you use the moment, or based on second method in which you specify the or you fix the axis system, and based on that axis system you change the sign of these four variables, you are going to get the same answer for the stresses. Okay, so now I am leaving it up to you to calculate the stresses by using both method for sigma d, and you can check whether you are getting the same answers or not. So I believe that this is one of the most interesting yet complicated topic for this course, this whole symmetrical or unsymmetrical bending. So you need to practice extra to be proficient in this one. You are going to get confused with this sign convention or with these orientations or movement. So as practice as much as you can so that you can be perfect in this one. And if you have any questions, you can ask me about this lecture.
सर एक्सक्यूज मी सर
Yes.
सर ये पहले वाले मित्र में सर आपने बी पॉइंट पे सर जो आपने एमजेड लिया है वो पॉजिटिव लिया है जो कि वो नेगेटिव में आ रहा है सर
mz नेगेटिव कैसे आ रहा है?
सर लेफ्ट साइड पे वो पॉजिटिव है ना सर
हाँ, तो ये mz लेफ्ट साइड पे आ रहा है, तो फिर
सर
मैं
बी
इसको
पॉइंट तो
पॉजिटिव
दूसरी साइड पे नहीं है सर
नहीं, mz की तो एक मूवमेंट है ना, उसका तो b पॉइंट से कोई लेना देना नहीं है, वो तो एक प्रिंसिपल एक्सिस पे मूवमेंट लग रहा है। डिस्टेंस के लिए मैंने b पॉइंट पे जाना है, ठीक है। mz की तो एक जो डायरेक्शन फिक्स है, वो तो मैं जब d पॉइंट पे भी लूंगा तब भी मैं यही लूंगा, e पे भी लूंगा तब भी यही लूंगा।
ठीक है सर,
ठीक। So any other question?